Hello, this is Group 18. The three modifications we get is security, add refueling station, and time-sensitive cooldown. I'll kick off with the security modifications we made. There are also minor functional changes from A3. For the display functions, we are displaying all orders in the stores instead of individual order in individual stores. So for security, we made a few modifications. First, we added MySQL database. And we have a backend that's talking to MySQL database in the Docker container through the GA internal network. We also have a front-end web interface through plain HTML. For security modification, we added the database because it will help us preventing the data loss while the program crashed. In addition to that, we also added user logins so that each command can only be executed if the user type has the permission to execute the command. Let me do a quick demo. I collected the list of commands I will be running throughout the demo. In here, I have my program running, and I will be going through the commands. The first command, make store, should fail because I have not logged in yet. As I mentioned, we have the login control, and each user has its own permission types. Make store is only available for the admin type. And we have created a God account with username admin and the password. As you can see, admin is right now logged in, and if you check the users tab over here, we have three users pre-created for the demo purpose. And I'll be going through the same command which was filled in earlier. And as you can see, a new store was added after the admin login succeeded. And I'll quickly go through all the commands over here. Paste all of them. So in here, I created 5 customers and a store owner. And I'm going to log out of the admin account and demonstrate that if I'm logged into a regular customer, it should not have access to the make item command. As you can see, operation is not allowed. This is because in our code, we defined a list of actions, and each action has a role attached to it. Admin is the God account that has access to all the operations, and the make item that we have specified is only accessible to admin and store owner that we created. So I'll log into a store owner account first. Let me do a logout of the admin account, customer account. Log into the store owner account. And store owner account is logged in. Let me rerun the make item again. As you can see, new items are added. And let me check here. Cloak is added, great. And we also have display commands over here for displaying items. Over here, as you can see, everything was working fine. And we also added exception handling if you put in a random store name that does not exist. It should say that the store does not exist. And let me demonstrate a case where the program crashes. So we have all these users stored in the database instead of the application, the backend application itself. So if I terminate the backend application, the program finishes. And as you can see, if I double click here, the data still persists. So that the next time you open up the program, you should log in first. Log into this. Login as the God account and displayed items. As you can see, the code that we created prior to the crash program still exists, and that's data persistency for security. And I will pass over to the next person.
I'm going to introduce the new feature of our group, refuel station. First, we have some test cases for this new feature, and I will run it first. For these test cases, it creates a store program at location 00 and 2 fuel station S1 and S2, and we assign order 1 to drone 1 and assign order 2 to drone 3. The distance between the store and the station, the distance between the store and the order 1 is 50, and the distance between 2 is 100. Let's go back to the program. After we run the command for time 5, now the 2 orders are delivered. The order 1 consumed 250 of the fuel, because the distance is 50, I just mentioned, and the fuel economy is 5 gallons per unit distance. So 50 times 5 is 250. So the last fuel should be 100 here. Same process as drone 3 did. After we deliver the orders, we need to operate the drone back to store. And there are 2 results. One is the drone came back to the store successfully and refilled automatically. And the other one is the fuel is not enough, so the drone will stay at the current location, waiting for the next step. So now let's test if the drone 1 can be back to store. We run the command back to store to send drone 1 back to store, and it shows a message the drone cannot fly back. So next we can try if the drone can have enough fuel fly to the nearest fuel station. So we run the command to station, clock drone 1, then run flow time. And there's no error message, then we run the flow time 5. Drone 1 now flies to the nearest fuel station, station 1, and the location is 2030. And the last fuel increased from 100 to 350. Now drone 1 can fly to the store successfully. Let's see. If we run the command back to store, clock drone 1, then run flow time 5, we can see the location of drone 1 has been updated. It has flight back to the store successfully. So now let's see. Test if drone 3 can fly back to stores. We run the command back to store, clock drone 3. It shows the error message the drone cannot fly back. Then we ask drone 3 to find the nearest fuel station. So to station, clock drone 3. It shows the error message there's not enough fuel. So now we can do is to dispatch an available drone to deliver the fuel to drone 3's location. We run the command dispatch fuel drone, clock drone 2, drone 3, 180. Means we dispatch drone 2 to carry out 180 fuel. So the last capacity of drone 2 increased from 500 to decreased from 500 to 320. It's similar like adding an order to a drone and for delivery. We run the command flow time 0.1, which means drone 2 is still on its way. The last capacity should be 320. And then we run the command flow time 4.9. Now drone 2 has arrived at drone 3's location. 6080. We can see the last fuel of drone increase from 50 to 220, and the last fuel of drone 2 is 800, and the last capacity of drone 2 back to 500. Now drone 3 can fly back to the store successfully. We run the command back to store, clock drone 3, and back to store, clock drone 2, and then flow time 5. Now let's take a look at the location. All the locations of them are 00, and the status of 3 drones are all false. Yeah, that's all the functions of these new features.
Okay, I'm going to introduce the second second major change of our final project, which is about the time-sensitive coupons flow. And this flow that includes 2 features. And so first of all, we have, of course, the coupon, and that applies to an order. And it will apply some discount, and it will also set a time threshold. And if this order cannot deliver on time, and the store will be fined by a certain amount. And in this case, we are going to fine the store by $10. And the second part of this coupon system is that we randomly generate coupons for users, but users with higher ratings will have higher opportunity to be able to use the coupons that were generated. And okay, let's look at this test case. So in this case, we are going to deliver 5 beer from the origin, which is the store, to 3040, which is a target of this order. And in order to save some time, I already run some comments in advance, which is we create the store and assign pilots, assign drone, and we have this beer prepared.
and we have the order and ready, and also the most importantly, the coupons. And we can see that there are two coupons are generated. The first coupon requires a rating of only 5, and the second coupon requires the customer to have a rating higher than 15. And our user only have a rating of 8. So we can try to add the second coupon, which requires 15 rating, and see what will happen. It tells us, well, we don't have enough rating to use this coupon. Oh, that's fine. Let's see if we can use the second coupon. And okay, so it looks like we successfully applied the coupon. And also we have assigned the Zhongzhong 2 to the order. And we also have this transfer order implemented. We want to transfer that order to Zhongzhong 1. And now Zhongzhong 1 is the Zhong who is going to deliver for us. And okay, let's we're about to purchase the order, right? I mean, for sure, I mean the order should be purchased first before it can be delivered. And now we can look at this. Oh, we do have a front end, surprise, surprise, and we can do exactly the same as we can do in the command line. And let's purchase this order. Okay, you see that there's something happened. I can refresh the page. We see, oh, the order is final, which means the order is purchased, and the total cost is it's 45, and you see that which is a coupon V90, which requires lower rating applied to this order. And oh, in addition, we do have a in-system simulation. Let's start the delivery. Okay, right now nothing has happened. And before we start delivery, we have to note that, okay, the revenue got changed because the order is final, and Kroger has made some money, and note that the expiration time is 9. And for Zhongzhong 1, I just tell you, it will take 10 time unit to reach the target. So after the simulation ends, the Kroger will be fined by $10. Let's see if that will happen. Okay, first of all, we want to make things happen slowly. We flow time by 5 units. You see that our Zhongzhong 1 already left the origin and it moves a little bit. You see it got speed and it caused some fuel, and it has some position changed, and that's the target of this Zhongzhong 1. And okay, fine. Let's check. Now let's move time for let's see, just 15. And see that the Zhong got moved a little bit, but it stopped at its target, and it automatically updates the order's information. The order is delivered, and it correctly calculated the delivered time, and the total cost is 45. And we noticed that the Kroger got fined by 10 because it failed to deliver in time. Yeah, basically that's the first part of the time-sensitive coupon. And you may have noticed that we generated some, just a random coupon got generated, and it has a expiration time. And we can flow time a little bit further. See 200. Let's try 200. You see that we have more coupons generated, and those coupons, they are just style coupons, and the randomability is guaranteed by the code. So this I represent the rating. So as you can tell easily, higher rating coupon will be generated much more easier than lower rating coupon. So that guaranteed our customer with higher rating to have more chance to use a coupon.
Now we will talk about architecture and design documentation.
As you can see on the screen, is shown on the UML diagram. It's almost same as A3 diagrams, and we add 2 more classes in there. There it will be coupons and stations, and also we add more attributes on the field class, and all the classes is going to be related. And next we're going to talk about deployment diagrams. For the deployment diagrams for the applications, we will be
compiling the program into the Docker containers. Demo delete all containers, run the 3 commands shown in the readme to compiling. Compiling backends and front-end containers. The containers talk to each other. As you can see, it's GA tag, GA tag underscore internal networks defined in the Docker compose file, and we expose portals to the Docker host as well. So in that case, we can check the output on the browser. Yeah, that's deployments.
Nice. Next is our sequence diagram. So we had start order, we had the request item, and also we have the transfer order sequence diagram. So you can see how customer can make a order and also transfer an order in these 3 sequence. We also have the purchase order. In here, we added the coupon. We added the coupon parts. We also added the refilling join sequence diagram. So you can clearly see how join refilling in this diagram. And next, we make the user case diagram. Different person interaction with different functions. So for example, the owner who has the access to all of the functions in the system, and also customer can sign up, log in, log out, and start order, and also all the functions listed in this diagram. Next is the state machine diagram. So in this diagram, you can see the function running trick, and also the last one I want to show you the database design. So we made the tables first and set the primary key and the foreign key for each table. And these tables connect by the foreign key and the primary keys. You can see the lines you can see the joining lines, and we'll know how these tables connect each other. All these diagrams we will submit on the Kevin, so feel free to download them and get more details. Thank you.